This will be the first video for section 4.3. Starting on number 1, let's read the instructions. It says use the graph of the function f to estimate where the derivative and the second derivative are 0, positive, and negative. Okay, so the key here is remembering that what we're looking at is in fact the function itself. So for question 1, it says, so we'll start with A, where is the derivative 0? The derivative is the slopes, so we're just looking at the graph and estimating where we think the slopes are 0. And we'll just answer with the x values here. And so we'll say that would be at x equals, looks like -1 and +1, because that would be where my slopes appear to be 0. Second part of A is when is the derivative positive? Derivative being positive is telling us that the slopes are positive. So we're simply looking at where is this function increasing, where are the slopes positive. And that, of course, would be anything in this section right here, because my graph is increasing, positive slopes, and anything over here. So it looks like our answer should be from -infinity until 1, -1, or from 1 to infinity. And then where's our function decreasing? That then should be, of course, where my slopes are negative. So all of these places would have tangent lines that have negative slopes. And so that would be between -1 and +1. Okay, part B says answer the same questions, but now look at the second derivative. So we know that the second derivative tells us about the concavity of the function. And as we look at this graph, we can see that in the section from -infinity all the way until, and my graph's a little bit off here, but until 0, because the graph, if you look in your book, it really comes down and hits 0. That would all be concave down. And then if we leave 0, then the graph shifts and becomes concave up. We have a bowl-shaped up. So concave down is a negative second derivative. So where is my second derivative negative? It looks like we should say from -infinity all the way until 0. Where is my second derivative positive? In other words, when am I concave up? And I appear to be concave up from 0 to infinity. And then when is the second derivative 0? That's going to be at the inflection points, which is the point between, or when the concavity changes. And we changed concavity at x equals 0. So that's when my second derivative should be 0. Okay, question 2. Same thing, we're looking at the function itself. So where is the first derivative 0? That's going to be any place where my tangent lines would have a slope of 0. So any of my local mins and maxes. So it looks like x equals -1, 0, +1. Where's my first derivative positive? That's going to be slopes positive. So it looks like I'm increasing positive slope in this area. So that would appear to be from -1 until 0. Then I go down, but then at 1, looks like I am increasing again. So, or 1 to infinity. Where's my first derivative less than 0 or negative? And that would be whenever my slopes are negative or whenever I'm decreasing. So -infinity until -1. And again, we're answering the x values here. And it looks like we should say or from 0 to 1. It's pretty obvious I don't have room for my answers to be, so I'm actually going to have to answer those below. So this is a question about, again, concavity. Second derivative tells us about what the concavity is. So looking at the picture, it would appear, let me just check it in the book real quick to see if I notice anything different. It's very possible that my graph is off a little bit. I'm indicating that the minimum value here is at x is -1. In the book, it appears that maybe that is pushed over a little bit. Maybe it's at -1.5. Okay, so I guess I need to be a little more careful with my pictures. I'm going to continue going with this picture right here. Again, these ones might really be 1.5s or something like that. Okay, so going off of this picture, my second derivative equals 0. Let's skip that. Let's go to second derivative is positive. So I'm looking for concave up. So I appear to be concave up. Let's change colors here. Let's go a green color. So I'm concave up all these places up until I'm going to estimate right about there. So I'm bowl-shaped up, and then notice here I become bowl-shaped down until right about here. Then it switches to bowl-shaped up and stays that way for the rest of the time. So where am I concave up? So the answer to this question, I'm going to be concave up from -infinity to, we'll say -1/2. Keeping in mind the real answer is probably a little bit different if you look at the book. And then I switch to concave down, but then back to concave up. And again, my picture is a little off. I'm going to estimate at 1/2 to infinity. So that's where I'm concave up, and here between those two, I am concave down between, again, my estimate, -1/2 to 1/2. And then when is the second derivative 0? That would be at my inflection points, which would be at these two values, which again, for me, appear to be x equals -1/2, +1/2. All right, we'll stop the first video here and pick it up in a second.